That's how you show continuity, right? You have to make sure the limit exists. F of 0 is 1, right? They're not equal, so it's discontinuous. Okay, let's try one now. Done? Next one, right? Online. Are you okay with this super? Online on the day? Let's go here. Let's take a look at this one here. Right? I want to sketch. Let's see if you remember how to sketch x squared minus 1. X squared minus 1 is shift where? X squared minus 1 is shifting. No, minus 1 is down, right? And then figure out 5 minus it. This way, my about to sketch those graphs and then we do it. Continue. That's it. That's it. I love it. Oh yeah, catch it quick, Ollie. Catch it quick. I gotta do it on the board in a little while. Yeah, try and sketch it. Remember, when it's less than -1 is 0. Here, that. And then let's check and see the continuity, right? I'm giving you 5 minutes. Graphing is very important, right? Don't be changed because remember the functions, plug in values, -1, 1, 0. Plug it in, it might take you a little longer, but at least you'll get in line in the curve. Right, even if you're struggling with the drawing, you should still be able to figure out the continuity part of it, right? Right, I like some of this sketches here. Help me out here. Right, so if you look here, when it's less than -1, it's 0, right? So I put in a hollow circle here, and I just color in this line, right? You don't really have to show it too much, right? That's not Barcelona video. Now I want to check on the Barcelona. The loss? Yeah. Right. Now let's consider between -1 and 2. Right? Between -1 and 2, how does x squared -1 look? X squared is here, x squared -1 is there, right? But we need to know what? We need to know how it behaves at -1 and 2. Right? So here's how you just figure it out. When x is -1, x squared -1 is what? -1, 0. That's okay? So it means that it's coming down here. When x is 0 is -1. What about here? Here's -1, right? Then when x is 2, 2 squared is 4, 4 minus 1 is 3. So it's coming all the way up to 3. Right? Is it hollow or solid here? Hollow. Right? Let's pretend that's 2 there. You okay with that? Are you sure? Right? So I don't want this whole graph, right? I am only interested in when the graph is between -1 and 2. So I don't want it less than -1, and I don't want it more than 2. Everything more than 2, I don't want. Because it's only defined between these two values. Right? So the way I found these endpoints is by plugging in -1, I got 0. Plugging in 2, I got 3. So that's how I know it starts here and finishes here. You okay with that? Now for this one, what is this? A curve or a line? A line, right? So I just go and plug in 2. Right? When I plug in 2, what would I get? I'll get 3, right? So the first point is 2, 3. And let's plug in a value more than 2 again. 3, right? 5 minus 3 is 2. So I'm going to plug 2, 3, and 3, 2 might be somewhere here. So you're going down here. Question. Do I leave here hollow or do I leave here solid? Solid now, right? Because when x is 2, y is 3. That is what your piecewise function will look like. Anybody confused? There you go. You okay with that? Fine. Right? So you have to actually put in the endpoints and see how it's behaving. All right? Fisher, you okay with this? You sure? Everybody okay? Why here solid? The reason why it's solid is that when x is 2, in the third function, in the third part, when x is 2, y is 3. Right? No plot in your book. Yeah, we think that's what the function. Guys, there? What's that? What is it up? Right, so the graph looks like this. Okay? First part, second part, third part. Yeah? Now I would like you check and see if it continuous here and here. Right? Check for continuity here and here, right? We check out online. Any questions online? Any Narayan, you're listening, right? All right, hurry up. Right, check for continuity, check the limit, and then check and see if it defined. Alright, let's go. Ready, Mikhail? Alright. So Mikhail, let's focus on x is -1 first, right?
It was Mikhail.
Mikhail. Right, Mikhail? Let's check out the limits as we approach. Let's approach from the right first, and then we will approach from the left. Oh, by the way, remember the minus goes to the top, to the top right hand corner, right? Right. So as you approach -1 from the right, what again? You sure? You're looking at the y value. So look at the y value when I reach -1. 0. And if you approach from the left, the value is what? 0 as well, right? So limit exists. Yep. Step 1, limit exists. Next one, Mikhail. Yeah. No. F of -1. What is f of -1? Does it exist? Is there a solid circle at -1? No. Follow and -1 do exist. So what do I write here? Do not exist. Right? It doesn't exist. So what the conclusion, Keshav? Very good. Very good, Keshav. Therefore, discontinuous. Very good. Do the next one. Hurry up. Do the next one, please.
Isn't it supposed to be like x-axis something? Not too. Yeah. But it's also really not What's it? I'm going to
Alright, sorry.
No, what do you ask next?
Right, let's go again. Beer. Where you going? Right? Access two. Let's pick on Joshua. Joshua,
He say on one word.
if you approach two
TikTok, TikTok, TikTok.
from the right, and if you approach two from the left. Don't worry with that. Approach two from the right and the left. Tell me where you get. Approach two from the right. What's the Y about approaching? 3, that's all. If you approach from the left, what value is approaching? 3, that's all. Does the limit exist? Yeah, because they're equal. Right? That's the first thing I write here. So the limit at x approaches 2 is what? 3, right? Yeah? Alyssa, what is f of 2? What is f of 2, Alyssa? F of 2 is 3. Solid, right? So we define. Are they equal? So therefore it is continuous. Everybody okay with that? All right, it's a little bad here, right? All right, it's a little jumbled up, but step 1, you find the limit. Step 2, you find where it's defined. Since they equal, continuous. Anybody confused with this? Right? Remember, you don't always have to draw a diagram, right? Sometimes you could just use less than and you could just use this here, right? You okay with that? So if you're approaching the right, just put 2 in there. Right? And it up. So if you're approaching, all your question. If you're approaching 2 from the left, which function are you going to use? 1 in the middle, right? Because 2 not defined here. So you're using this one here. So you're putting 2 in here. Huh? Yeah, 2 defined here. So 3 minus 5 minus 2 is 8. You okay with that? Anybody got? Anya, you okay with us? Sure. Confused?
Yeah.
Try this one here. Everybody, try this one here. Adam, let's do. I pronounce the name right? Yes, please. Oh yeah, try this one. Alright, remember new class next Saturday, yeah? I thought that was on today. Huh? No way. Oh yeah. Try this one, please. Are you erasing this, right? Right. Do you have to draw this one? You don't have to draw, right? Good. Right. This one they go in reverse. They tell you it continuous. So if you know it continuous, you have to apply these rules here. So you're working in reverse, right? The question said it is continuous. Right. But this here, right? There you go. This one here, we know it continuous. So what does that mean? We know it continuous, so it means that the limit as x approaches 2 is equal to f of 2. That's okay? We know it now because they said that the limit exists, right? So let's see what we could find now. Could we find f of 2? Right? Which function we going to use to find f of 2? First one or second one? First or second? Because 2 defined here, right? Right? So f of 2 will be 2 squared plus 1, which is 5. That's okay? So what will the limit be? As x approaches 2 of f of x will be so the limit of f of x as x approaches 2 is 5. Okay? Now, how do we find limits? How do we we'll see that now. Right? How do we find limits? To find a limit, we know that the limit as x approaches 2 from the right, let's do from the left. Anyway, it don't matter. Let's do from the left. From the right, from the right, which one is right and which one is left? Which one is right? Which one is left? More than is right. Yeah. So this is from the right. We're not too interested in that. We're more interested in the left because we don't know this, right? So if I approach f of x from the left, what the answer is? 5, and Jordan. So if I approach from the left using this one, what you do? And just plug in 2 in here. Yeah. So you'll get 2b minus 1 is 5. We know the answer because we know it exists. So 2b minus 1 is 5. 2b is 6. Therefore b is 2. Okay, now? Alyssa? Richard? Gotta begin for this one. Huh? You all okay with this? So this question, Lucas, we're going in reverse. They told us it's continuous, so we know this. So we're checking to see which side we know. Do we know this side or this side? It appears we know f of 2 because we can plug it in here and see f of 2 is fine. Right? So now we know the limit is fine. How do I find limits? As I approach from the left or the right, that will also feed us. It don't make sense of working with the right because I know again fine. I'm interested in this side. Right? So I plug in 2 in here. 2b minus 1 is 5 and then solve. So some questions they ask you to prove, some questions tell you it continuous and you work in reverse. Let's go again. Abhidam, let's go again.
Yes, you could be a little sick.
Look it up there, that's you. Try this please, 2014. Try 2014. F of x, they give it, to tell it continuous. Yes, finding.
Now it's just making sure if you know you can have a big.
Find a some of this. No.
Please.
Online message answer to A, please. Which one is left function, right again? If you have to approach on the left, which function are you using?
No.
You had to approach from the right, you see? Go ahead. Set it up, find P. Right, fine, but A, it didn't specify for. Fine. I don't know who this thing is given us.
Yeah.
Do this now, please. Finance.
So, see. Yes.
Why have X there? You don't have X. It's in one set. Right, you're missing just one little thing. So you know the limit as you approach 3 is equal to f of 3. Right, it's up to you. You can do this fast and this. F of 3 is what? F of 3 is here, right? So that, in fact, you do it again. We have 2 minutes. So some people get it. Some people get it.
Sure, I'll copy. All right, nice. Now you see what you got? So f of 3 are using this here. That'll be a by 3 squared. That'll be 9a. Now let's check out the limit. The limit of x approaches 3. The limit must exist. Let's check it out from the we use from the right, so let's check on the left. As we approach from the left, that will be 3 by a plus 2. Remember, as you approach from the left, all you have to do is drop in 3 here. As you approach from the right, just drop in 3 here. Okay? So we got 3a plus 2. We know these two. Since continuous, we know that these two things have to be equal. Right? We know that 9A has to be equal to 3A plus 2. 9A minus 3A is 2. 6A is 2. A is 1, 2. Are you okay with that? There you go. Sure. Right, so you have to check it here and here. Oh, sorry. You have to check left and right. Okay? Every question is very related by the same principle. Sometimes they give you a value, sometimes they don't. Oh, wait. The average before the. Yeah, we got like a 50, 20. You're okay with us? Right, remember you're looking, you wanna solve A, so you wanna get an equation with A in it, right? Okay, if you want, you don't have to do it like this. You can check the limit as you approach from the left and the right equation, and you'll get the same thing. Right? Find a way to get that equation to solve. All right? All right. Before, actually, I'm gonna give you point to that, all right? I think we're gonna have the wrong thing. All right, let's try this next one. I really can't remember this one here. Where's one on these? All right, try one more. All right, let's try one more like this before I change it up, right? Last one, try this please. Try this last one here. Try this earlier.
9 months.
I have find for B. Online message answer now, please. Anybody confused? Who? Sebastian, you there? Hey.
So you just put them on this.
Alright, y'all done? Y'all got you? Let's see what happened, right? So we know it defined up here. F of 2, plug in 2, I got 5, right? F of 2 is 5. So now the limit of x is the limit of x approaches 2 is 5, right? Just plug in 2 here. So I got 2b to be 4, I got b to be 2. Look at that? Next, simplifying limits. Simplifying limits. Simplifying limits. Alright, watch this here. Let's say you have a limit looking like this. Right? Watch this here earlier. Stefan, watch here. Isaiah. Right? So if I set a final limit, right, of 3x minus 1 of x equal to 2. All you have to do is just plug in 2 here, right? 3 by 2 minus 1 and you'll get 5. Simple, right? That's what we've been doing all the time. For after the final limit, just drop in the number. Right? But suppose I ask you to find the limit here. What would happen? If you put in 1 here, you'll get 1 minus 1 over 1 minus 1, which is anything over 0 is what? anything anything divided by zero is undefined, right? Right? So in a case like this, whenever you get something undefined, right? Whenever you get something undefined, it's in an indeterminate form, and you don't want that, right? Sometimes these things will lead to actual values. So in a case like that, you have to try and simplify. And there are two ways to simplify. Number one, we could factorize. If number one does not work, then we divide by the highest power. Right? And L'Hopital is just a check, you're not allowed to use it. Right? But you're not allowed to use it as a proof, right? Yeah, but watch this here. This one here, can I factorize this? Yeah? Let's just see, right? I will get the limit as x approaches 1 of x minus 1, x plus 1 all over. So this x minus 1 will cancel. And if I plug in 1, my final answer is 2. So this undeterminate form here, undefined form, is really 2. So every time you get something undefined, you have to check and see if you can simplify it further. Right? First method you use is factorize. If that doesn't work, you divide by the highest power. Okay? Right? Take this note down. When simplifying limits, if an indeterminate form is obtained, any one of those you can consider indeterminate. If an indeterminate form is obtained, then we can simplify by number one, number two. Number one, number two. Right? Factorize.
So yeah, I'm the correct factor.
Nah, you have to try factorize. Don't work then you.
Yeah. So, somebody will bring it up, we'll have another 82 minute forms by the end of the day, value is still infinite here at the end, right? Right, and you wrote this example down, I know it's kind of bad, not looking too nice, but. Write this down now, this one here. Right? Right here, then here, then. Here. Yes, sir? 1 plus 1 is 2. Not bad. Not bad at all. Right? And anyway, I'm not sure on the layout at all. I don't know. I'll show that next. I won't think about you. Right, remember this is module 3 and module 3 is only limits, differentiation and theory. Or sending out the crash course timetable sign up form tonight, right? Or take a look up. Something like that's something I didn't common purpose.
Because he
You can post it up on, but that's just people who play. So you will get a booklet and you're not coming into that. Alright, let's try one again. Right, remember if factorization doesn't change it, then you divide by the highest power. Go ahead. Try this one here.
That's what we are. Yeah. And we don't like, it's not like, it's not, I guess so far.
Hurry up. Right, and then during April, after the crash course, you will identify at least 5 topics that we could just review alone. And if you don't like tricks, you just focus on tricks or what else. And that's. Huh? Hurry up, find the limits. There's some occasions where we skip it. I'll try to find it back and show you. Right, that point if we do it in this order, it won't go. Right, anyway, online for these hopefully paying attention. Nobody's sending answer, so. Obviously, we could click on Sanji for that. Absolutely. Amrit, you there? Go on then. You there? Sarah answer now. Right, let's see what you got when you simplify it. And then I have to give you all the rules for limits, right? What you got here? When you factorize, what you got? X plus 3. And underneath is what? X minus 3, x plus 2. Just cancel, right? And then you plug in minus 2. So you'll get minus 2 and 3. Right? Plug in minus 2 and 3. I got 1 on minus 5. All together. Let's go again. Try number 3. Adam, you remember this expansion? What is E cubed minus P cubed? Step back now. Oh, you factorize it, yeah. Open it and then close it. Right? Plus 2AB minus anybody remember this? When we did main the factor theorem. So I just give you this to remind you here, right? Huh?
Why the person? You don't go for the way you absolutely. That's great. I don't know what they look like.
Why can't we say what one again?
I mean, that's.
Just factorize something about them. Finish? How much you got?
A 6.
One. Alright, let's see, right, the limit. The limit at x approaches 3 of, factorize the top. And here will be, 27. All right, and it's like this, right? 3 cubed. So x minus 3 by x squared plus, where you got? 2 by 3. Sorry, 2 by 3 by x, right? 6x. Plus b is 9. This will cancel, then you plug in 3. You'll get 6 over, what's this here? Huh? How much? 36. 1 6. Yeah. Let's try one more before I give you the limit rule.
What?
I like a bully away.
Sì, ma lo srong, lo srong è spazio. Io la causa
Is x and b is 3.
Plus 3
3 by 2 is 6. Huh?
3x. X squared plus 3x.
X squared plus
3x plus 9.
which one?
That's
Oh, here I mean by 18. No, it's 2 by 3. And it's 2 AB.
Yeah, AB.
Siya bagi note siya. Just siya bagi note from man si please.
Just expand on that and see very simple.
Ah. Yes, it's plus AB all here.
Here it says. So I cancel. I don't know what yeah.
Right? I made a mistake here. AB, not 2AB.
Say I'm not.
Right? Yeah, so we could check and make sure as well. That was one, then why the answer was 1/6. Watch this here, right? We can apply Le Hospital here. It's not something that will give you any marks, it is a check. Right? If we use Le Hospital here, how Le Hospital is work. You can differentiate the numerator and differentiate the denominator. Right? This will cancel. And then whatever you get, plug in next to 3. So you'll get 2 9s. Okay? But Le Hospital does not give you any marks. It just allows you to check the answer. So you still have to use the 2 methods I give you. Factorize or divide by the high power. Okay? So the mistake was here, right? I made a mistake number 2 there. I think I was listening to later on. Right? But Le Hospital is simply differentiate the numerator and the denominator until you get a determinant fast, right? Right, let's just do one more. Online, any question? Do do that now. Last one. Try this one here. Last one here, earlier. Try it, factorize it, do work, simplify.
So we don't look.
Me?
Yeah.
I went to Richard. Right, try this one. If it's not factorizing, then what you do, Joseph? If it can't factorize, what you do? Divide by the high power, right? Every term by the high power. Right, we have one more little thing to do in this, right? But put it each other. Alright, so we will continue, right?
I'm sure after you can get.
If you know after, you know it's undefined. Yeah, you know it's undefined. But you can do that and show it in the right, but you're. No, but nothing wrong with that. So this thing was all like. Right, all these questions are coming with the info, they're already halfway through. So good for yourself, isn't it? That they wouldn't give you some that not they will
So we use this.
so you can achieve how. That's what I'm gonna grab from Sunday and we go. I see how they progress slow and time. So that's the one how much people dress. All right, last part. Right, what you all did here? Right, factorization will not work, right? So what you'll have to do here is divide by the highest power. And the highest power is squared, right? Right, it was squared, right? So it's 6x squared on x squared minus 1 on x squared by 3x squared on x squared plus 8 on x squared. Right? This will cancel, right? And when you plug in infinity, you'll end up with 6 minus 1 on infinity all over 3 plus 8 on infinity. Anything divided by infinity is what? 0. So you'll end up with 6 minus 0 over, and your final answer is?
I get
Yeah, well, we went down to the end.
I don't think you can ask something.
Yeah, you will still get it full mark. You have 6 on 3.
I guess 6.
Pardon me? X up to 10 to infinity, what? Come here. No, it's not possible to divide by 0. Right? Well, it's possible, but you'll get something undefined. We sure you know your answer, huh?
See, I think you have to include the limit as like separation infinity of 1 on x squared is 0.
After we substitute?
Yeah, so that we go to shit. And then they have to state the limits of 1 on x squared as like separation infinity is 0.
No, I don't.
Well,
No, we substitute, we remove the limits and we substitute. So this, all right, I see what you're saying, but this means as x approaches infinity, what the value is. That's what this substitution is here. Huh? For this, I'll show you a solution, right? And you will see identical to this, right? But no, but I understand what you're saying, right? But when you reach here, when you reach here, the next stage is the substitution part. So you don't have to write back the limiters and the limiters, right? After you write this, the next stage is to just put in the infinity value, which implies that 1 on infinity as x approaches infinity is 0. So you don't have to come back here and write the limiter anytime. Okay, after you write this, the natural step is this, where you substitute the values and you work it out. All right. I think even if you look at Bahal book, yeah. All right. We have one more thing to look at in limit, right? We have some rules to look at, right? And the rules help us simplify limits as well. So for example, if I want to work this out, I don't have to work out the fraction like this. I can work out here and then work out the limit up here. and then simplify it out. Right? It wouldn't work for this one, I'm in general. Right? Like if I have 2 here, I could find the limit at the top and bottom. Right? I could also split it up. Find the limit here minus the limit here. That's okay? So the rules I'm going to give you here are the rules that you could apply for limits, right?
Yeah.
Right, watch this here. These are all the rules for limits, right? We had to write all those rules down, right? Watch this here. I want to go over the rules. Watch here. If you find the limit of a constant, the limit of a constant that x approaches b is just a constant. That's okay? Now it's straightforward. Anybody recognize these limits? What do they look like? You all did rules like these already. Huh? Summation, right? So limits and summation have some similarities, right? Okay, so watch. So the limit of a constant. What you see, the limit at x to the n is just putting b to the n. If I have a sum, I can split it up individually and do them. You okay with that? Yeah? We're almost done. We're almost done. Here, I can take this C and pull the C on the outside. Anybody can tell me why? Why it is for that particular one, the limit as x approaches b of CF of x is the same as just pulling the C on the outside. Why it is the same as just pulling the C on the outside? Right, because remember I showed you in the first one, the limit at x approaches b of c. Right? What this is? C. And I see? Right? So technically you can just pull the C outside, just like integration or summation. Next, whenever you have a product, you can find the limit of each individually. In a case like this, if it's a division, you can find the limit on top and below. This one here really important, right? When we're doing first principles, you will need this one here, right? The limit of f of x to the power n, I can pull the n on the, I can pull the power on the outside, right? Because it's the same thing over and over. If it's 3 times, you find the limit by itself 3 times, right? So if this is 3, you can pull the brackets on the out, you can pull the 3 on the outside of the whole limit. And lastly, if it's square root, same thing. You can pull the square root on the outside. That's okay? There you go, all right, get down. Or you can take a picture and keep it.
Yeah.
Take a picture and keep it. But you're right here, right?
Yeah.
Right, there's like 2 more questions on them your stuff, right? Right, you go all along, about 15 minutes and then you'll get it. I'll give it 15 something and 15 something. So you'll get half. Oh, less is whatever, we can do more. Good pressure, then go to school. Right. I'll have it. Right, just take a picture and keep it, right? The most important rule is the last 2 and the first 2. Last 2 here. These are 2 special limits that we need to know. Right, that one next one, tan bar will brush that city, right? That one tan as well. But we will just use it 2 of those.
Yes, you are. So yeah, already proof of us, just so we get one.
Proof?
The actuation, they asked us to prove that tonight. Yeah. I have to call you. That's it. Let's say they give us 4 months.
Huh?
You come out like months.
Yeah, no fun. Digression on Ahmad Alpha. And actually, you wanna read it, the digression on.
So I'm just saying, I'll go on to. I do it all by myself.
If you do it all by yourself, you get some.
Yes, that's it.
But it's nice to know. It was no. I do that now. I see that. But I went, we just find. Right, so these are some rules that we need to learn, right? That's what keep it. But it's nice to know. That's it. It's nice to know all the proof facts. Okay, this one down, right? Let's try one now. Huh? You have it?
Because you make a deal. Yeah, absolutely. He volunteered. I didn't volunteer. I wasn't in the country. I wasn't in the country and I make me happy. If you have anything left, you know. That's just anything for anything you decide to get out the day, choose what you want to do. You wouldn't have to. I carry clothes. I said, Michael, have you need it? You don't want my. I didn't know I said that's. I should have been set on a.
Alright, what's here? You ready? We're done?
Yes, we do. I finish it. No, I do further. You finish it? Yes, I finish it.
Oh yeah, follow up, nice quick now. Okay, that is quick. Probably have any cap. Alright, let's start now, yeah. Hello, girl. Break this now. Look at you two.
I went out with you at Swaziland and I'm giving out center. So what's the
Alright, ready?
So what you said, chicken?
Right. So let's take a look at the rules, right? Number one. Ready?
Yeah.
Right? If we apply the rule here, what's the limit of sin x on x approaches 0? 1. Right? Always remember that these two things must be the same. If I have 10 here, I must also have 10 here. What about here? Right. So the only way I could use this rule is if I have 3x here and 3x underneath. They must be the same, right? So I'm going to multiply 3 on top, 3 underneath. Right? This will now become, the 3 goes here earlier. Please don't multiply 3 by 3 and get 9, yeah? 3 goes in front. So you will get 3 sin x over 3x. Right? What can I do with this 3? Put it on the outside, right? You use rule number 1. And now, this is what? This value here is 1. So it's 3 by 1. So the answer is 3. This case now, what do I do? Right? This one here, can I multiply by 3 here? Keshav, can I do that? No. So, I need x here and x here, right? So what I could do is I could factor out the 3. And I will get 1/3. And I will get 1/3. That's okay? So when I factor it out, and now this value here is what? 1. So the answer is 1/3. What about here? Copy down. Let's come to this one. Let's do it step by step.
What you said you bread or what you said chicken?
Copy down. And let's do number 4. Alright, ready? Right. How do we work out this here? Right? In order for us to, I know most of you all can watch the answer and figure it out, right? What's the answer? The answer is 4 and 2, right? But we have some steps to follow in order for us to get that. So first thing we do is we break it up. We use the division rule and we write it like this. Limit as x approaches 0 of sin 4x divided by the limit as x approaches 0 of sin 2x. Right? In order for us to work this out, F1, we need sin 4x over what? 4x, right? And we need sin 2x over 2x. Right? But the only way we could do that is if what? The only way we could put up 4x here is if we multiply by 4x, and here multiply by. So it's like the same thing we did here. Multiply by 4x and 4x, 2x and 2x. Right? But in order for us to simplify, we can't just come and cancel off the x here now. Right? The correct thing to do is for us to expand this out.
So we will get the limit as x approaches 0 of sine 4x on 4x. We know this already, yeah? It is a product, right? So we write it like this. The limit as x approaches 0 of 4x all over the limit as x approaches 0 of sine 2x on 2x by the limit as x approaches 0 of 2x. Now we know this is what? Adam, this is what? And this is 1. So now we have the limit as x approaches 0. What can I do with this 4? So I have 1 here, and I'm putting the 4 on the outside of x, putting the 2 on the outside. Right? The 1 comes from here, the 1 comes from here. What can I do now? This will cancel. Yeah? And now I have 4 over 2, which is, right? But you have to write this statement because you have to use the limit rules. Right? You can't magically cancel off the x and put 4 on. Alright? That's okay? So you know what you want to get. You know what you want to get, multiply it by it. You know what you want to get, multiply it by it. Please don't cancel these x's, right? Can't do that yet. Because this is the limit that you're finding here. Right? Then try and prove this, huh? Try and prove this. No, I want it.
I can you not finish that. You are the and you know everything. Okay, I want to I really do Everybody now fucks that fun. Everybody laugh. Yeah. I know I'm not sleeping. Myself, I'm not sleeping. Yeah, I know. No, I don't know.
Yeah, how we doing this? Sign over cost, nice. Right, so tan is sine theta over theta, right? And what will happen is theta flip up here. So you'll get the limit of this. Kind of making no sense as yet, right? Can I break up this? Huh? Oh, no. I write it wrong. So you end up with limit as theta approaches 0. How can I break this up for it to make sense? Right, sine theta over theta by, right? And then I could use the limits of both of them. What's this value here? This value is 1. What's this value here? Cos 0 is 1, right? 1 on 1 is 1. Yeah. Are you okay? Yeah? Right, what time is it then? Let's squeeze in one more. That? One more and then I'll get you up, right? Polita ready so totally good. Anya, Sharona de, Alex de, Jordan, Akila. That's Akila. Emma online, Serena, Joseph, Amaret, Savira, Dante, Cleo, Sebastian, Nathan, Mitchell, Rima, Luca, Redwan, Nathan, Spencer, Zachary, Alzahir, the next Mikhail. Sultan Rehana. Sapir was online. Stefan. Ramprasad. So you one behind there too. Idan. Ashad. Wait, that's two Ashads. Mohammedan. Rahmat. Ahmed. Adrian. Sanjeev was online. Tiana. Christiana. Sarah. Adriana. Adam, Alyssa, that's right. Keely. Ambika. No, yeah, we have one person. Push ups, I like it. Ambika. Nothing, beer. Nothing. Ethan, Lisa, Ashley, Isaiah, Joshua, Isha, Amara. Alright. Supposed to give you one more, right? On the board. What have you done? Alright, one for the road, one for the road. So that's what was the fun. Hey, you gotta be a road man, be not a road man. Not a road man. Say, Last one, try this please. Last one, are we done? Let's simplify that, right? Hurry up, that's the last one there. Last one, are we done? Yes, sir, yeah, man, good no. Zachary, are you up now?
Yeah.
Zachary, why didn't you do it?
Last one. Last one.
No, I did not.
So, I didn't do it, the one had a school.
Huh?
The answer is two. So, like, but that one's ready, I'm done.
Right, so next, we have no class next week. After that, we run over limits and start first principles, right? But we have, yeah, but we have more questions on this to do some harder one. Complete number. This, like, number. How much now? When is market come? I think first week, second week, in March. You're done? Benjamin, much you got? Right, Isaiah, stay up now. Adam, what do I divide by? What did you divide by then? 2x, right? And then also multiply by 2x, right? Right, I'm trying to save some lines here. What do I do now? Right, so I can back out
2x on the one on top.
I mean, it's. Huh?
Right, and then trying to save space on, and all right, the next line, right, well, what will happen next, Tolia? Right, the 2x will cancel. Right, the 2x will end up cancelling in the end, right, but I'm supposed to write one more line, but I don't have more space, right? And then plug in 0 on top, you'll get 2, and underneath is 1. So the answer is 2. Right, the 2x will cancel from here and here. Right? And then the 2 will cancel. So yeah, final answer is 2.
Yeah, so
We're working, say working. Alright, take a break now. Take a